Okay, we're gonna get started because it's 1:05, so we're kind of just a little bit late. And we'll just kind of wait for people to come in. I just want to make sure we are mindful of people's time. So maybe all of you can sit down while we get started. So actually, Ed's gonna make just a quick announcement about what the plans are for the boards and stuff.
Oh, sure. So we got a lot of questions about this. So let's just take 1 second and give it up for Leah and Jill, who are doing an awesome job. They're so busy they won't even turn around and look. We're getting a lot of questions about the boards. We think they're fascinating. One of the things we're doing at the end of today is we'll be taking high-res pictures of all of this, and we're happy to share them back to you. Because they're a good capture of your thoughts, and they're a good opportunity if you want to keep driving them forward for some of the research collaborations.
Okay, great. So with that, we're going to go ahead and get started. So we have, just like in the morning session, we have 4 presentations today. So John Lee is going to kick it off, and then Asa, Shamsi, and then myself. And then we're going to, again, take a 20-minute break, and then basically break you out into groups again. So don't forget that we have all of these like Post-its on the table. So please use them as freely as possible. And we put up some clean sheets for you to go ahead and put up. Okay? All right, so with that, we're going to go ahead and get started. So our first speaker is John, and I'm just going to let him take it away.
Great, thank you. And it's been just a pleasure working with you today, and the rest of the conference has been amazing. What I'll be talking about is trust in automation. There's a paper I wrote with a graduate student back about 15 years ago, and some of the material I'll talk about here is from that. And unfortunately, that paper, like most papers, has lots of problems. And graduate students and I are working on an updated version that hopefully addresses all of those problems. And the title is important. We're talking about trust in automation, but also trust through technology. So how you develop trust in people that are represented or communicated to you through technology, I think is important. Research is sponsored by NSF, NASA, Toyota, CSRC, also a collaboration with J.D. Powers, figures in this talk. I'd like to acknowledge them. These are my students that make all this possible, and this is my super cute dog here. In the textbook we wrote, we have a section on his relationship with our Roomba, which is relevant here because sometimes the stakeholders that you design for, the people whose trust matters, may not be the people you think. And in this case with the Roomba, the dog is somebody they should design for, but I don't think they do. What I'm going to talk about first is why does trust matter? I think it has a powerful influence on behavior, particularly as technology is becoming increasingly agentic and smart. Second, what is trust? It's a multifaceted concept, attitude, and I think also a relationship. So it's relational as well as attitudinal. How much should we trust? More is not necessarily better, as we heard from some of Eric's experience, maybe over-trusting his Tesla autopilot. We want it to be calibrated with the capability of the automation, the trustworthiness of the automation. We also want it to be aligned with goals. Is the goal of the automation the same as the person? And then finally, who is trusted and who is trusting? Who are the stakeholders beyond the direct users? Incidental users like pedestrians may not trust the automation. We heard a number of people concerned that they would be able to keep riding their bicycles. I ride my bike, I don't drive my car, I don't want to get killed. I want to trust the automation to keep me safe. Here's an example of trust in automation gone bad. This is from the NTSB investigation of the Tesla crash. This is kind of a mundane picture, a little scuff on the truck. The other one is too disturbing to show because it took the top off the Tesla and the head off the driver. And what's interesting is this illustration of the degree of trust in the technology. Autopilot was active during this gray period. Out of the 40 minutes or so, 37 minutes autopilot was active. These are points. The yellow is when there's a visual warning. The green is when the hands were on the autopilot. I think hands-on time was about 7 seconds total. So touch the steering wheel, drop down. Worked beautifully for 37 minutes until it didn't. Person trusted the automation. over-trusted the automation. So in terms of why does trust matter, it guides behavior, as we see there. It guides behavior in a way that I think is underappreciated. Don Norman wrote a book on the importance of emotion in how we relate to not just automation, but in general design. Tony Damasio has written a beautiful book on the influence of affect and emotion on decision making. Trust matters because it influences behavior. It influences behavior as we relate to technology. As technology becomes more human, more agentic, it is more active and engaging with us. It might have a voice, it might have eyes. When it gets like that, we tend to trust it, tend to respond to it as if it was a person. A lot of work with Cliff Nass shows that. Trust is active across a broad range of relationships. It's multifaceted, as I mentioned before. From the micro, how we trust the defaults of our computer, the spell checking and so on, to kind of a meso, how we trust a brand. We believe Microsoft is out to protect us, is on our side with respect to privacy. That's trust. But also at a macro level, how we value money is trust. Paper in your back pocket is worthless. It's all about trust, as is democracy. Democracy relies on trust. I thought it was interesting, Bill Gates was saying how education is the core flywheel to society, and then he backed off and he said, well, actually, trust might be more important. I agree with him. So what is trust? This comes out of the collaboration with J.D. Powers. This is a quantitative look at qualitative data, looking at a network of topics from comments on a survey of people's trust in automated driving. I'm not going to go through this in detail. I become fascinated in text analysis. But I think what's interesting here, trust when mature, technology is improving. It conveys the idea that it's not just about technology now, but people also trust in the future. They trust that it's going to get better, that it's going to improve, and one day it will be sufficient. So that's one view of the complexity of trust. This is another view of the complexity of trust, something I'm working on as we speak. This is a kind of word cloud, but based on word embeddings, extracted these words from 16 items for subjective ratings of trust. So items from 16 different papers that present ways of measuring trust subjectively. So Likert scale ratings, these are all the words from that, and arrayed so that the similar words are near each other using word embeddings and then UMAP to spread it across 2 dimensions. And what you see here is kind of a nice cluster of things related to trust. It's dependable, honest, reliable, sincere, timely, correct. And then interestingly, these are the sort of focus of the trust: the brand, the robot, the technology. So moving on to how much do we trust? This I thought was a great slide from the presentation yesterday, quote from your CEO. Building trust in technology is crucial. Completely agree with that. It starts with us taking accountability for algorithms we make, the experiences we create. Completely agree with that. And ensuring that there is more trust in technology each day. I disagree with that last phrase. I would edit this to be more trustworthy technology. You want to make sure the technology has integrity. And that is the important point. Trust ideally should be calibrated with its capability or trustworthiness. You don't want people just to trust your technology more. You want your technology to merit the trust. And that's why I edit that phrase. Calibration, one way to do it is through transparency. You make it more obvious what the algorithms are doing. But there's a surface and depth component of this. The depth component is how it's actually behaving, the reliability, the dependability of the system. The surface is what's on the surface, the colors you use, the font choice that you use. Apparently lavender, if your car is infused with lavender, you will trust the autopilot more. So that's a surface feature. Obviously, that's a way of increasing trust without necessarily increasing trustworthiness, and that could be dangerous. Calibration through control, this is something missing from that first paper, I think is really important. being able to control and feel how the automation is responding to you pushing it in one way or another, exploring it through that is really important. So this shows the problem of this trust and trustworthiness. Trust is your attitude. Trustworthiness is the capability of the system. Ideally, you'd be on that line of appropriate trust. What can happen is hopefully you'll be here, but you might be here where you trust things much more than they merit. And this is the calibrated trust. You're in the Tesla, your hands are on your knees, your eyes are on the road, ready to take over at any moment. Here is reality. I gotta get a better picture, but that person's dead asleep in the car, trusting way more than is appropriate. And Linda's standing up, so that means I have 3 minutes, 1 minute, 2 minutes?
1 minute.
Varieties of control, really important point here. Obviously, there's the pragmatic, you're controlling to achieve a goal. It's also communicative. You control to signal to others. You also control to learn about a system. You tap the brakes to see if it's icy. But control is for self-efficacy. Control is what makes us feel like we matter in the universe. So control is really important. Springsteen put it maybe best, and in driving this is really important. People feel like they want to be in control. So communicative control, this is a paper by Josh Domeyer looking at the way vehicles can signal to pedestrians. It's through control, not just lights and arrows and verbal signals. Who's trusting? I think this is really critical because oftentimes we're just looking at this, the driver and some automated element, but really the driver is in a network of elements that need to be considered in total. So it's not just the driver trusting the technology, but it's the pedestrians trusting the technology. It's those incidental users out in the environment. And it's also not just the vehicle technology, but the technology that's arranging the ride shares and the people who are riding in the car with you. And if you're a woman in Iran, talking to one of my students, she does not feel like she would trust a lot of the people that she may be paired with, guys that may be paired in the car. So who you get paired with, that network of your trusted riders could be really important. So with that, one thing to give you some food for thought, HAL 2001: A Space Odyssey, trust, capability, started out good, appropriate trust, highly capable system, and then Dave lost trust, unplugged HAL. But if you take the macro view, HAL was working for NASA, not for Dave. HAL was working fine at the end. He discovered that Dave was getting in the way, terminated Dave, or tried to, for the sake of the mission. So is that appropriate trust? Was HAL actually working the way he should? Did Dave lose trust when he shouldn't? Maybe he should have just died quietly and let the mission go on. But with that, I think my time's up.
Your
So
time's up.
thank you for your attention.
Great, awesome. Okay, yeah, we can clap, sure. All right, so Ed's going to go around. If you have a question, here, and then Jesse afterwards.
So one of the things that I feel like we focus a lot on is capabilities and then confidence and capabilities of agents or automation in general. And it was really interesting to me to see your previous slide, actually, where it was capability and trustworthiness, where HAL's capability never changed. It was highly capable. Yeah. Yet there were other aspects that changed the trust. And it was so great to see honesty as well as one of the words. And really, we focus on capability, but I also want to know that my autonomous vehicle is honest with me, that it's telling me that, oh, it made some mistake and it's not quite good at handling pedestrians, being fair, and maybe in many ways reflecting my morals or perhaps ethics of a broader society, being benevolent. And we really don't focus enough on it. Trustworthiness, we very often equate with capability. So I'm curious a little bit more, if you could comment a little bit more on that.
Yeah, great point. And this is something that, as I mentioned, that first paper equates trustworthiness really with capability, and I think that's not a complete picture. And I think there's multiple elements of that, but one that's really important is goal alignment. Here we're assuming that the goal, the classic Hal betraying Dave, the goal alignment was imperfect to say the least, right? So trustworthiness, part of it is the alignment of the goal. And the second half, aligning with asset was great. Still highly capable, still doing what it should. With driving, the goal alignment is problematic. So the pedestrians, the vehicles are not aligned with their goals. In fact, it's a game situation where the driver and the pedestrian are negotiating or competing for the right-of-way. More generally, when you optimize, who are you optimizing for? The individual, the traffic stream, or the traffic and the pedestrians? So it's complicated that way. So I think as we move into these more network systems, the goal alignment becomes an element that complexifies capability.
So Jesse has a question, and then Don, but before I get started, so we have a few new people here. We have Post-its on the table, so as you hear comments, because our goal is to try to generate research ideas, please jot down some notes and plaster up on the thing. And if I see that you haven't written anything in a while, I'm gonna call on you to just plaster something on the wall. So Jesse, you, and then Don, go ahead.
So John, I want to hear about your idea regarding the concept of calibration. So without gold standard, there is no calibration. So I'm kind of thinking about what is the gold standard of trust? Say now, previously there is assume like Tesla autopilot works perfectly, but then suddenly it make like an accident. So like the person's trust should decrease, but then on the x-axis, where the gold standard, we know that the gold standard, we should not trust it completely, but where the gold standard will move and to what extent it will move.
So you're not going to let me off the hook with this, are you? Because we talked briefly before, and I thought I sidestepped that whole issue well, but so it is really complicated. So this trustworthiness, one element that I didn't mention is that there's a time period to this. It's a dynamic, it's not the same. So with Tesla, it can be really good, and you can have your eyes off the road, but then as we were talking before lunch, that car moves out and you're now the head of the queue. The capability of that vehicle is dropped in some sense, and it should demand your attention to the road. So there's a dynamic component that is really important to consider. And so I think the trick, there's two parts that make it difficult to measure, is the time scale of trustworthiness and how you estimate that, how you quantify that. And that's tricky. But then trust, how do you measure that? And part of that measurement is maybe through subjective scaling, and that's why I've pulled together 16 of these papers that have different measures of trust, but also maybe more importantly, behavioral measures of trust. And we've got a couple of papers looking at how people respond, like with vicarious steering, for example, to get a sense of how engaged they are.
So Don, did you have a comment?
Several.
Uh-oh.
First of all, I really like that diagram, and now a but. Because actually, I think the right-hand side, the two dots should be together. Because the real question is, who is viewing the diagram, or if you will, when it says trust, it's trust by whom?
Yes.
So capability is capability of the device, and trust is trust by Dave. Mm-hmm. And so in that sense, the two diagrams are correct. But if you now say what is about trust from the NASA's point of view, the diagram on the right should have the two blues. So actually, in other words, maybe you need three diagrams to demonstrate that point of view is critical in assessing trust.
Yeah.
The second point I wanted to do is you can't make a system that tells the driver what it's not capable of doing, because it doesn't know what it's not capable of doing. And we have unexpected things that happen, which, well, the whole point about unexpected things is, first of all, they happen a lot, and second of all, they're unexpected. But I think a really good problem, and this, I want to just say this to get it in the record for the discussion period. There's the problem of trust and overtrust is probably the more difficult problem in many ways, because we work hard to cause people to trust. And as the Tesla example and medical examples show, that's a problem. But how do you design displays that and I would like to recommend not using the word trust, because that is a very loaded term, and so I don't know what the substitute is, but I'm going to say effectiveness. And one thing we know is if you have a map and you show a dot, and that says where you are, but the system doesn't really know. So suppose you show a dot that's shaded and blurred, and the radius is a function of its uncertainty. And the same philosophy could be used for a lot of the information in the automobile. One of the things that people are trying is the car, often for the test purposes, shows a picture of what the car can see and with outlines around the objects it's identified. And that's often far too complex for everyday people. But it's a start, and I wonder if there's a way. And then the last comment is, and I know you know this, is for the record. The famous Volvo accident, the car actually did detect the pedestrian, but the certainty fell below its threshold for reporting. But if it could instead give us a certainty measure, one that's not disturbing though, because this is going to happen a lot, but showing that, yeah, I think I detect something, but I'm not certain. Yeah. Something that indicates that, not the words, et cetera. So this is for the further research discussion.
Okay, I'm going to allow one more question, and then we're going to let Asa start. Oh, I'm sorry.
So there was actually a couple questions in there. The first one, I agree with you completely. This problem of interpretation here, I think, has to do with goal alignment, which was missing from that first paper and a problem that I hope to rectify. And then on the point of uncertainty, one of my previous graduate students, Bobby Supplet, actually wrote a really nice paper on using sonification to indicate uncertainty. So background awareness supported through auditory cues of how the automation is understanding the world. I'm not sure if that's going to work when you want to play your Bruce Springsteen as you're driving down the road, but it's a start.
So quick question.
Okay, quick question. For the trustworthiness, from technical side, definitely we can make the software and hardware more secure and more robust. But how does it really, like mapping back to the how trustworthy it should be in a conceptual level?
So as you make the hardware and software more robust, how is it reflected?
Right. Back to your graph about trust and trustworthy.
Yeah. So I think that as you make the hardware and software more robust, that's going to increase the trustworthiness of the system. And then hopefully if that's represented well at the surface and depth features of transparency, and if you give people the right amount of control so they feel engaged with it and understand it, that should increase their trust to hopefully the level of capability that you've given it, that you've improved.
Robust is the wrong word. Robust sort of implies that it doesn't break. And the problem is really capability.
Or resiliency. If I was Dave Woods, I would say it's supposed to be resilient, which I think is a good point. So resiliency, robustness, capability, words we should think about as we develop.
So I think this is a really great discussion that we'll have like as part of the breakout sessions when we talk about trust, because it sounds like a big topic. So let's give John a round of applause. And our next speaker is AJ, and she is going to be talking for 10 minutes.
I hope so. I'm going to try to be really quick. I know Linda manages a tight ship here, so. Hi, everybody. I work with Eric and Bessa and with Gagan, so I'm going to kind of try to cover our joint work in the space. And I think this is going to be kind of a shift because I'm going to take more of an AI perspective. Like, as someone trying to build AI systems, what is the role of humans in these systems? What does that mean for the self-driving car experiences we've been talking about? And what kind of capabilities we should be putting into AI systems so that they can really utilize this human in the loop, having a driver in the car, much better than what the current systems are capable of. So to do that, I want to start with just overview of what a machine learning pipeline looks like. How people are building machine learning systems today, and this actually includes the self-driving car functionalities as well. If you ask a machine learning person how they are building these systems, they are going to give you a picture that's kind of on the top. I get my favorite data, I chunk it up to a training set and a test set, optimize the parameters of my model, look at the accuracy. If I'm happy, if that's better than the past accuracy, I'm very good. However, as we are looking into real engineering pipelines, especially the work going on at Microsoft, we are seeing that humans are part of every step of the development lifecycle, and also they are the users of these systems. So humans are a big part of how these systems are trained, developed. They give the objective functions. They tell the machines what they should be doing. They are part of the execution of the system, because every time a Tesla car gives a warning light and says, please help me, it is actually getting a human in the loop for reliability purposes. And finally, our real goal is not really getting the most accurate machine out in the field. Our real goal is really having the machine that provides the most value for the human. And that's, I think, what the purpose of AI development should be. And I will just try to make a quick case for why we think about human in the loop so much. There are multiple reasons. They are quite general, but I think they apply to self-driving cars or semi-self-driving cars as well. First of all, unless AI systems are perfect, there are actually particular complementary strengths we see from humans and people. We see this in medicine, but I think the car settings are really interesting for me because people and machines have different sensors to perceive the world. So it is quite unlikely that something that is failing the LiDAR of a car is going to fool the person. Or when a lighting condition goes bad and the human cannot really see much, it's going to be the same problem for the machine. So we really want to see what that complementary strength looks like. John actually mentioned the ethics, the value judgments question, which is... No, I'm not gonna. That's not my favorite problem. I actually feel that that is a superficial problem that just, gets us out of the real problems. But at the end of the day, though, we still make value judgments. Every time an engineer puts an objective function into a system, they are making a value judgment. It doesn't look like the trolley problem, but they are making a value judgment about how fast the car should be going. In which settings it's okay to override the traffic rules because maybe people are not following the traffic rules as it is written in the book. So all of those are actually value judgments that are going on into the systems. We need people to debug these systems and figure out how they can be improved with data collection and so forth. But the main thing I want to talk about today is the role of joint execution for reliability. We know that the cars on the street today are not perfect. They actually fail a lot. And the only reason we can put them into the world today is our reliance on the people as correctors of these systems and have that virtuous feedback loop back to the companies, because every time a human corrects the Tesla car, that's a signal that the car or the bigger company can use to improve the algorithms for these systems. So I just want to talk about why these failures happen and what is the reliance on the human. With AI algorithms requiring a lot of data, we rely on these kind of platforms. This is AirSim from Microsoft. This is a simulation platform. It's available for drones. It's also available for cars. A lot of the car companies are using these kind of simulation platforms and reinforcement learning to build the algorithms that are going into the cars today. And when you look into it, it is nice, nicely lighted. There is like a street. The car kind of bumps up here and there and then finally learns how to drive. However, this is how the real world looks like. This is quite different than the simulation platform. This is the screen from the Uber car when, unfortunately, the car killed somebody, a pedestrian, during the drive. So what we are seeing is that there is this mismatch between the simulation platform and the real world. No simulation platform can capture the complexity of the real world. And because of this mismatch, our current algorithms have blind spots in them. They cannot really learn all the features that are important to function in the world. And when they get into a space where this outsider that is not represented in the simulation is in the real world, they fail and they have no idea that they are failing. So these kind of confidence scores, being able to signal a person, they completely go out of the window when we have these kind of mismatches between the training platforms and the real world. So what we did in this particular research paper, this is just one step towards giving computer systems the capability to know what they don't know, is we actually used human data, human demonstrations and corrections to teach machines what they don't know, build these maps of confidence, and then use them to be able to hand off decisions to humans. Of course, right now, this is all happening in small toy problems that we can kind of do in our machines, right? This is not real self-driving cars. But I think this is one algorithmic step we are taking to enable the machines to know more about their capabilities. But the problems in this driving space are not limited to machine blind spots. Humans have blind spots too. This is why we are excited about the prospect of self-driving cars. What you see here is a human blind spot. So we should really think about where machines have blind spots, where humans have blind spots, and really have algorithms that can reason about both together to really think about control very much. So in our follow-up work, what we looked into is really like how we can collect data both from the machines and humans, bring it together so that we can map out the space of complementarity, really figure out who is a more reliable, I know you don't like the word, I think robust was the word, right? Reliable, is it a good word? Who is a more reliable actor in which situation, and we can manage the control that way. So the last point I want to make is that unless we can really make those kind of algorithms work and build agents that have a good understanding of their capabilities, we rely on humans and we rely on their trust. So the way that when I talk to Eric about his experience with the Tesla, the way he describes his experience is that he watches the car. He watches what the car can do and cannot do. And through that, humans build mental models of trust. And they say, in the street, I can trust the car. I don't have to watch over a lot. But I know this exit is problematic. And at this exit, I should be watching over it very carefully. However, all of these cars, like any software, gets updated all the time. It is just one of the problems that we have when humans are in the loop, but our AI systems are not designed and optimized for having human in the loop. These objective functions for updating models have no consideration for the human trust. It has no consideration of the human mental models. And when that happens, an update can actually kill the mental model of the human. So there are actually a lot of new insights we should be putting into the development of AI systems for them to be human aware, human considerate, to really reason about new capabilities going beyond of accuracy that can sustain that partnership between the human and the machine. So we did a little bit of work on this with Gagan, and we are continuing our collaboration right now, where we looked into the role of updates, machine learning updates, in the human-AI collaboration. So the expectation is that I have the blue agent, human learned about the blue agent, the green agent is a better agent, I move to the green agent, together we get better. If things are not compatible, if the updated agent breaks the mental model of the human, this is the situation we get. And we actually verified this situation with human experiments. And what we can do is actually add a term for dissonance into the objective function of the machine learning model that penalizes these kind of new errors that break the mental model of the human, and actually can get machine learning models to be compatible with human expectations. So this is just one way we can be more considerate, be more human aware in the development of AI systems. And why this is important? Because unless we can get perfect AI systems in safety critical situations, we have to rely on human trust. They are our key for reliability. That is why we have to really think about the human side in the development of AI systems. And that requires think about the humans from design to the development of the objective function, thinking about the improvement loop we develop in our engineering practices.
Could you back up and explain that graph? What are the axes?
So what we are doing is that the original objective function for machine learning models only care about the accuracy in a data set. What we are putting in here is that a term for dissonance that is actually penalizing every mistake.
What does ROCH2 mean?
I will get there, but I need to explain this first. Okay? So what this is saying is that whenever you are making a mistake that you were getting before, that human would trust you with, I'm giving you an additional penalty term. So that's what the objective function does. And this compatibility score is actually watching that. It's watching how many of the things it was getting right before, it is getting right now. So how much our trust is kept or broken. This is like a percentage. And the y-axis is the accuracy performance of the AI algorithm. The AI algorithm is going to be most accurate if it has no compatibility to the past. It can just optimize the hell out of the data set. So that's why the points on the tab, so the 3 lines are different optimization functions, different dizziness terms we study in our paper, but focus on the blue one because that seems to be doing the best. What you see here is that you get most accuracy when your compatibility is low, but you don't have to sacrifice actually a lot of accuracy to get to a higher level of compatibility. You can kind of continue that function quite a bit. But if you really want to get to a lot of compatibility, you have to start sacrificing accuracy. So our idea is that we want to give these kind of graphs to AI developers when they are going to be updating a system. They can look at these graphs, and actually they can say, this is the point I'm willing to be. I have to be at this accuracy. That means I will have this much compatibility with my past models, and maybe I'm going to have a strategy to communicate what has changed to my human user. And we can talk more about this at the break or something. So I'll stop there. Yeah.
Okay, great. Thank you very much. Okay, that's it. Thank you. All right, so we have some time for some comments, discussions, questions. Anything? Okay, John? Well, hold up a minute.
Really great talk. You mentioned dissonance and the degree to which it's compatible. How do you quantify it? What constitutes a mental model breaking change versus something that's just different that might not be noticed and might not matter for the person?
That's a great question. We are kind of taking a kind of a simplification approach there. What we are doing in this paper is actually saying, anytime you were getting right before, I assume that the human has learned to trust you with those. And if you start making mistakes on those instances, it's going to be really problematic because I had trusted you. Now the machine is making a mistake, and I'm not going to be really aware of that mistake. I'm not going to be able to correct you. However, in many settings in practice, people have personalized experiences. So they develop trust in different ways. Their experiences dictate where they are going to be trusting more or less. So actually, the better way of doing it in the future, which we don't know how to do yet, because we really don't have computational models of trust or mental models yet, would be really thinking about the personal experiences of people, try to model what that trust looks like, and put that as a component into backwards compatibility.
Great. Any other comments? I also want to again remind people to go ahead and put up your Post-its, and then Andrew will walk around and take a look at them. So if you have Post-its and you haven't put it up yet, please do. I guess no more questions? All right, then let's give her one more hand, AJ. And our next speaker now is Shamsi. Yep.
Give me a few seconds as I get set
Yeah,
up.
you can, well, you know what? Let's take this time to write some notes, like write some research
So
questions.
use these micro
or
moments to get
topics.
things done.
Yeah, go for it. Yeah,
I know.
multitasking. Microtasking. Yeah. Yeah, you can stay. Oh, really? Okay. Oh, wow, that's great. Yeah. You should join us. We're really cool. Okay. All right, I think Shamsi's ready now. So
I'll give
let's
people a couple of seconds to finish what
go
they're
ahead,
doing so
finish
that
up your notes, and then
we
we're
can
gonna let her
start at
get
a break
started.
point.
Yes. Okay. Ready? Let's go.
Okay, so I know
Okay.
that Linda started her stopwatch.
Started the time.
Awesome, I already lost 2 seconds. So we are going to move from automation and trust back to work And we already had some very fruitful discussions during the first session in the morning. And I'm going to continue on that and kind of like talk about a couple of projects that we have done about work in the car or in the context of when you're commuting. So, oh yeah, it's nice to have this now. So again, getting things done is no longer confined to the desktop anymore because we're commuting. We have mobile devices that have increasing capabilities. We can basically carry work with us everywhere. It's not necessarily a good thing. It's just that we are starting to have that capability more. And the key point that also came out today is that we are spending a substantial amount of time commuting. And think about the cities of today is that people are being pushed more and more out into the suburbs, which means that they're commuting more. Some people have remote working capabilities, most people don't. So that is kind of like lost time in productivity. And so we are thinking about, are there opportunities to make use of that time? And that's kind of the core of this entire workshop. So we know that driving is no longer a single attention task, and I just wanted to point out like 4 scenarios, which I had also briefly brought up this morning, so I'm not going to belabor over this. Primarily manual cars, continuous attention is driving, and we could have opportunistic interleaving of other tasks. We have talked about this this morning. Connected car, where is that you just have broader range of multitasking capabilities because now you can talk to the internet and the cloud. Semi-autonomous and autonomous, so I know that someone had talked about it being more about self-driving cars versus non, but there's this weird spot where self-driving cars are not always self-driving. And so that's where driving becomes secondary and you have to interleave just like paying attention to the road so that you're ready for takeover. And then finally, autonomous, where cars drive themselves, where you have potentially full use of the commute time, but there are other design considerations around that. So this is this limited environment, it's moving, and all of that. So we talked about this in the morning. We all know that engaging in something is attentionally challenging, and how do we design tasks so that it can deal with that limited attention scenario. So there is a flip side. We know that we do a lot of mind wandering when we're driving because typically we don't have anything else to do. So driving sometimes becomes so automated that you can allow yourself to think about different things. But it also means that mind wandering can negatively impact your focus on the road, and it's kind of like how you're able to control your conscious thoughts that gets lost. So there has been research that shows that strategically placed concurrent tasks during your driving can actually help people be more vigilant and focus on the road better. So there's some opportunity there. We listen to music, we try to talk to other people so that we're alert and not falling asleep. So there are also, and I had hinted at this in the talk this morning, is that there are moments during the driving where we feel that we might be able to handle things better than other times during driving that we know, or at least we should know that we can't handle other tasks. And then thinking about new experiences for semi-autonomous and autonomous vehicles is that what are some of the things that we can do in the car? So I like to think of this as kind of like these 4 aspects. So one is that what are some of the non-driving tasks that we can safely do in the car? Now, if I tell you that, yes, go ahead and write your Chi paper in a car, which is not self-driving, that is probably not the right thing to do. But we're already doing some of the things in limited attention environments. And we have now assistants that are making their ways into the car that are potentially going to help us with some of these things. Just because an assistant can help you, it doesn't necessarily mean that the tasks are designed in a way that it should be presented to you in the car. So I think that there's a design opportunity there, is that your assistant that helps you at home, like Alexa or Siri, the interaction there is very different than what the interaction in the car should be. And so that is also another design opportunity. We talked a lot about microtasks this morning, about kind of like thinking about tasks that do not require sustained attention, and how can we break it down to a level where it makes sense for the user to do that task, but also take away that interdependency that, well, the next task that I'm going to do needs this task to be completed before I can move on to that one. And then finally, and this is also an area that is ripe for research, is that we're not only designing for drivers in the car, we're designing for sometimes the passengers. My Highlander does not let the passenger actually put in or interact with the GPS system when the car is driving. So I'm not driving, so I should be able to do that, but it doesn't let me. But also thinking about, I mean, a passenger in a driver in a self-driving car is kind of like a passenger, and let's assume that's fully self-driving. But again, it's a moving environment. How do we design especially in keeping in mind things like motion sickness, keeping in mind the resource constraints and all of those things. So I'm going to talk about 2 projects. The first one was not necessarily done with the car in mind, though it was motivated. And the second one was we really wanted to push the boundaries of thinking beyond just the communication level tasks. So this is interesting because I know this morning some people talked about kind of like, so I want to not necessarily carry on work all the time. I need to be able to detach from work at the end of the day. And particularly people look at cars being the place where people start disengaging from work and they start ramping up to home. So that was my motivation about thinking about, okay, so how do we kind of like use this time as people are transitioning from home to work and work to home to allow people to disengage and reattach to work after a while. And there is evidence in occupational health behavior and occupational health therapy and organizational behavior, which shows that adequately being able to detach at the end of the day actually helps your productivity in the long term. And reattachment, when you come into work, probably everyone starts off with checking their email, getting caught up with the things that they want to do, checking maybe their to-do list. And that's where kind of like you are spending maybe half an hour trying to get ready for work. And so we were thinking that can we move some of those actions out from the desktop into when you are coming into work. So we developed a conversational agent that asks only a couple of questions at the end of the day to help people disengage, and then brings back that information the next day as they're walking into work, and so that kind of like to get them in that frame of mind. This agent was not used in the car, so I will make that claim right away. And part of the reason is that we didn't want to do that study in the car. We wanted to see how effective these questions were. So it was set up as people could use a Skype client to actually interact with the agent. But it could definitely be used in the car, and I'll show a video in a bit. And these questions were super simple. What did you do today? What do you want to do tomorrow? And how do you feel about work today? And how do you want to feel about work tomorrow? And the next day, it just brings back that information and asks you, what is the first thing you want to do to be able to do that? So I am going to quickly switch to a concept video, and which is, let me see, it's not this one. Yeah, it is. I did open it, but now I've lost my mouse. No. Oh, you know what happened? That it just.
Just gotta drag it over to the right.
No, that's fine. I will start from here. I thought I could open 2 instances.
Hey, Cortana.
Hi, Alex. I know you had a big day today. How did it turn out?
I'm feeling pretty stressed. I had a few things to do today. I made edits to my paper, finalized the study design for my study, and started the code base for the new project that we're working on.
I might be able to help with some of those things. If you had to pick 1 or 2 things that you want to do first, what would they be?
I'd love to get the bugs addressed by noon tomorrow. Also need to send Kelly an email with the latest code changes.
Cool. I set a reminder to send the email to Kelly for tomorrow morning. And it looks like you have an hour free between 9 o'clock and 10 o'clock. Do you want me to block that out so you can work on the bugs?
Sure, that'd be great.
Done and done. We can revisit the other things tomorrow.
So again, this is a concept video. This does not exist. Cortana is not at this level, but this is kind of like to showcase what we are envisioning with this. And this is Alex, the intern who worked on this project. So we thought it would be nice to showcase it.
Morning, Cortana.
Good morning, Alex. Did you sleep well?
Not too bad. I've got a busy day ahead of me, and I'm ready to get started.
Let's do it. First off, remember to email Kelly when you get inside.
Okay, I'm done. Thanks for the reminder.
Anytime. And now's the time you set aside for those bugs. If you want, I can hold any emails that aren't urgent until after 10 o'clock.
Would you? Thanks.
Okay, so that kind of showcased what we are looking at in terms of this experience. And so you might notice that it was totally speech-based. And it was kind of these short interactions, and it sounded like a conversation that you would have in the car. Now, we then wanted to take this a bit further and see that, well, can we push the boundaries of things that we can do in the car? And I see Don looking at me. And so again, this is an experiment. We wanted to, and this was particularly motivated by the fact is that we can take these bigger tasks and break them down into micro tasks. And so are there parts of a bigger task around PowerPoint or around document editing that we could actually present in the car in a safety-aware manner? So this is kind of like the simulator that we used, and this is very conversational. So this, again, to just highlight that this is not what we intend to do. And no, and so when you think about non-driving tasks for the car, so again, this is a speech-based interaction that we're looking at. Conversational agents could be, they're getting better, but you could also embed awareness about safety because a lot of information that these agents could use is coming from the car. So what is the car speed? What is the environment around it? We could use sensors to be able to figure out what the cognitive load of the user is. And so we could use all of that information to kind of filter the type of task that we even allow the user to get engaged in. So again, that's where microtasks come in, and we have discussed what we think about microtasks. So they're not necessarily at the very level where it doesn't make sense anymore, but things that people can quickly do without having to depend on the task before or the task after. And again, alerts were the other options that we're thinking in terms of the safety. So I'm going to show another concept video because I think that that showcases what we were looking at. And let's see. I don't think we need to have the whole thing. Nick is working on a presentation he is about to deliver in a meeting. Imagine Cortana keeping track of where he is in the presentation and helping him with the final touches as he drives to his meeting, while also making sure he drives safely.
Hey Cortana, where were we?
You were working on the motivation slide.
Perfect. Let me get through this intersection first. Okay, I'm ready.
The title screen says motivation. Do you want to add text or graphics on this slide?
Yeah, let's put a picture of an autonomous car on it.
I found a picture and added it. There is a bicyclist to your right.
Got it.
Do you want any other text on the slide?
No, I'll speak over it, but make sure that the picture is really large.
Okay, that's done. Check the slide before your presentation.
In case you didn't see, a picture of an autonomous car is automatically inserted there. So again, we're nowhere near this, but in the future, we could imagine our assistants being as smart, and so that they can do these kind of things for us. But one of the things, the other things that I did want to point out is that if you notice the interaction is very fluid, it is allowing the driver to pause, it's completely speech-based. Of course, there are questions around, okay, so I am now working on my presentation or even thinking about my presentation, and so now I'm visually starting to think about it, and how is that going to contradict with my driving? And so, of course, there are those kinds of scenarios that we have to think about. And that's why designing work for the car is so interesting, is that how do we suggest these microtasks, and how do you kind of like get a measure of what the cognitive load is going to be, and how is it going to interfere with current work? So the research questions here, and I'm going to quickly go over this, is that we wanted to see how the secondary task structure or how the microtask is being presented by the agent, how does that impact people's performance? And the context support, so the support about the road, how does that influence the driver's safety needs as well as their needs to be productive? Okay, so very quickly, people, I'll probably go here. Drivers seem to be split on the task structure question. So some people like the agent to be kind of like very, very directive, and they would answer the questions like, okay, does this slide have a picture, yes or no? So other people hated it, and they would rather prefer that I would dictate something, go and make it work. The good thing is that the drivers did not think that they could create polished documents, nor did they think that they should, but they felt that whatever they were dumping in terms of thoughts would be useful to carry on later. Many drivers said that even though they might not do something that is coming from the Office Productivity Suite, they thought that just thought capture or creating to-dos would be a good thing to do in the car. I'll skip over this, and it's kind of like implication for design is that support for safety is important in these environments. So it's not your regular desktop environment, neither is it your mobile phone environment when you're moving, when you're on the go. Tasks should interleave with driving, and so the tasks should be designed in a way that they can be easily not only engaged in, but you can also disengage from them very easily. And there are only some tasks that are going to be driver friendly, and trying to put in everything into the car, that's not going to work. And on that happy note, I'm going to open this up for
Great. Thank
questions.
you. That was great. Does anybody have questions, discussions? And don't forget to write. So quite a few. Wow. So yeah, let's do that. Starting with Duncan.
Great. The PowerPoint thing while driving, it's a nice idea. So what if it can't help but react, there's little moments of like going for, I think of going for the scenario you presented there was a person driving to the meeting. And to me, that's like standing up and going for a walk and getting some distance from the work. And it's interesting that you chose to focus in on the on more edits being done. It was like about adding content to the slides, or the kind of stuff that you would traditionally do at the desk. Whereas, I don't know, my personal reflections on how that goes down usually is it's when like the talk is rehearsed in your head and you're reconstructing that high level, I'm getting nods, yeah. You're reconstructing that high level narrative. And so it was interesting that you chose to, the interactions there are all about put this figure in, add some text here, whereas you could imagine an alternative here where it's like you're talking through conceptually what you're going to be talking about, the structure of it all, and things are being rearranged. The slides themselves are not being edited, but they're being rearranged conceptually, right? So the overall structure of the talk is being worked on.
I think
so it's a different level of abstraction.
It's definitely that, and I think it boils down to where we felt at that point would people have the more cognitive load. And from my personal experience, and I have used the car to actually rehearse stuff. And those are also the moments when I have felt that I have had no awareness of my driving. I managed to reach from point A to point B. I have no recollection of how I got there, so which is scary. But I think it's a good point thinking about, okay, so what are the things that would not require me to have continuous attention on a task that is not driving. If we go back to the self-driving cars, I think that's actually a perfect scenario. I mean, it doesn't require you to visually get engaged in anything, so there's no setting of motion sickness, but it's a perfect thing to be able to do in those kinds of scenarios. But I think it's also person-dependent.
Andrew?
Shamsi, this is really cool, and I really like the fact that you have an assistant who's thinking about helping. And I wanted to point out that, data both in experiments as well as looking at data about crashes shows that having a passenger decreases your chances of getting into a crash. So is it because of, what kind of interactions go on? Of course, you don't quite know. But the fact is that, having a passenger there probably means talking to the passenger, right? So one question would be, how would you do this task if it wasn't Cortana, but it was, you and I are sitting there, you're driving and you're telling me what to do. And it intuitively feels like it would be pretty safe. So I'm really always curious about how we might be able to learn from those human-to-human interactions and improve. So I don't know what your thoughts are on that.
Yeah, I think one of the things that also came from the previous talks is trust in the system. So, I mean, right now I wouldn't trust Cortana or Siri or anyone. Even I may or may not trust a passenger in the car. So it's a matter of when you're thinking about manual cars, you always need to be vigilant yourself, but also learning from these interactions between passengers and drivers. I mean, so passengers would point you to things. I mean, I would say an alert passenger would point you to things in the road that, okay, so keep an eye on that, or maybe talk or maybe reduce the amount of cognitive load that the conversation is having. So those kinds of things. I think there's definitely things to learn about there, but there's also some good points about systems is that they can do some measures that maybe a human can't. So if you're looking at wearables, you're looking at all the car sensors that could be put in a car, and awareness about, okay, there's traffic coming up, or this road has suddenly changed in terms of the density of cars. So those kinds of information maybe a passenger may or may not be able to pick up on, but a system might be.
Albrecht?
So one of the questions for me is sort of, what does it do to our workload as a whole? So I have done some of those scenarios with a human assistant. So on the motorway going through my email and quite regularly. And I find this, even with a human assistant who is very well knowing what I do, extremely tiring. So I usually arrive and I feel I have done a lot of work. So I did this very often on longer motorway drives, like 1 hour, and I felt this sort of, I arrived at work and I felt I had worked sort of for a number of hours. So for me the question is sort of, is putting this into that context of driving, has anybody looked at what it does to our perceived workload? So I think these things, and if you study them in the lab, that's a different thing, but so it's very easy to study them with a Wizard of Oz. And my feel is sort of, you feel at the beginning this is really working extremely well, but once you arrive, in contrast, when I have listened to music or to podcast, whatever, sort of I feel quite relaxed when I arrive. And so technically there is not really a big difference, but I find it quite taxing doing that. And so did anybody study that?
So we have a project that we're hoping to get some information.
Yeah, I would. Right.
Yeah, so me, Andrew, Orit, and John, we actually have a National Science Foundation project trying to understand how much of a workload it is to actually do work, and what is, are we actually, oh, sorry.
So can I, one more, so I think it's not really, I think it's the question, not of the workload in the moment.
But it's the task,
residue.
the task.
Yeah.
To your day, to your week. So, and I think this is sort of something I think it's a bit like sort of looking at a bigger picture rather than at sort of this immediate short,
Right, that's a good point.
So
I would
Linda,
like
can you
to-
repeat what he just said? Just
So what he was saying, what Albrecht was saying was that it's not just about the moment-to-moment, interactions, but it's more of the big picture, and then long-term, what is the effects overall? Is that right?
So I want to add one point to that. And so, I mean, in case there is a misconception, so I am not proposing that we do more work in the car, but there are, and if you look at the first one, that was actually helping people disengage from work so that on the way home, you're not really thinking about work anymore. You can start ramping up to getting to home. The other part is that sometimes there are work thoughts that would be there automatically. And so what we're looking at is that are there effective ways of getting those thoughts captured so that you can actually you are able to relax and you are able to listen to music rather than thinking about, oh, I have this meeting with Eric and I have to think about all the points that I need to make during those meetings. So, I mean, that's at least one of my motivations to think about how can we use the time in the car effectively, but definitely thinking about the well-being of the person. That's another key part of the research that I do.
So one sentence comment. So I think once we have created it, our employers will want us to use it, and we have to. So I think coming back to one of the talks yesterday on ethics, so once we can work in the car, we are expected to work in the car. And we had this with one.
So just to repeat, basically what he said was that, once, we have this feature and we're able to use it, our employers may actually demand us to do it. And is that a good thing or bad thing from an ethical perspective? We're just going to take one more question. I'm sorry. So go ahead, just go ahead.
Okay, it's Flora from Melbourne RMIT. So thank you, Shamshi. I wish my drive scenario looks like that. It's very relaxing.
Neither does mine,
But the thing is, I think what is missing really is a lot of tasks happening, especially in the first and last mile of the drive. So, for example, give you a couple scenarios. For example, I know now the traffic's building up, and I'm going to be late. I have to find a car park where I usually get my train to work, right? And I know if I'm not catching that train in 5 minutes, I have to write that email to my 10 o'clock meeting saying I'm going to be late, and there will be repercussions along the way. And I have to say to my students maybe, hey, I will have to cancel my meeting with you because my 10 o'clock meeting is delayed, blah, blah, blah. A lot of things happening in my mind. So these are the micro tasks. And I think I personally think we're still far away from the scenario of drafting Word document, but I think these are the low-hanging fruits that we should be tackling. So my question to you is, have you explored the sort of taxonomies and categories of tasks, these micro tasks, that people might have been thinking while they're driving? So it could be, we've explored something like this in our other projects, but it's something maybe, it could be a navigational task about, where to find the closest car park. Is it something to do with finding something? Is it a finding task? Is it searching for information? So these kind of little micro tasks.
So this morning we did have one group talk about what
Sorry, I
things
missed
people
it.
want to, no, that's fine. What people want to do in the car, and I believe that some of these communication needs came up. And the scenario that you described, I think that's a perfect example of that. Yes, I do need to send that email because I am worried that I'm going to get late and I need to get this information out somehow, and I suffer from that repeatedly. So I think that when we think of productivity tasks, I think that it's not only creating content or managing content, it's also about these communication needs and how can we design those to happen in a safe manner.
And one thing, I don't know if it's also discussed here, because I do work with a lot of road safety experts. One way to actually measure how much you are paying attention to the road, to driving task, is actually even the way you drive. So, for example, if you start swerving around a lot, and I guess that's when your intelligence system maybe should ask you and prompt you a question: are you okay? And what are the things that bother you that we can help?
Yeah. Absolutely.
Yeah,
I will
great.
switch over to Linda.
I hope it's okay. Let's say thank you to Shamsi. I just want to make sure that you guys get coffee, and so that we can go ahead and do the break. And then, by the way, these are really great comments. So for those of you who I did not get to, please go ahead and write the piece of paper, your comments, so that we can tack it up, and then we'll try to group people together to discuss. So I'm going to go ahead and do my last presentation. All of you can get even on me now and take time to find out if I'm going to be able to keep within 10 minutes. I think I can, though. So. Oh, yeah, that's true, right? No. So, oh, God, why didn't I think of that? No, I'm just kidding. So I'm just going to wrap up by talking about, everything that we discussed with regards to trust, using our vehicle in the car, and then what happens over time when we use automation. And so I'm going to talk about just adapting to technology in our cars. So I spent a lot of time looking at behavioral adaptation, which is basically when you have extended use of a system, what happens to the operator and how their behavior may change based on use of it. And oftentimes it changes in ways that's unintended from the person who actually designed the system. And this change can be based on many things, in addition to like what the situation is, the context, and it's often based on how much experience we have, how familiar we are with the situation, as well as what our motivation is for why we're driving to begin with. But what's very interesting is that, as technology has evolved, technology is right now adapting to the limitations of the human, but we are also adapting to the limitations of technology. So we're adapting to technology while technology is adapting to us. And so from that, then, we see these different types of implications. And there's actually many types, but for this particular workshop, I just wanted to focus on the perception of safe driving. What do drivers think is actually safe when over time they're able to do more and more things, and they were able to do it without actually getting into a safety critical incident. So then therefore the amount of non-driving activities while driving then starts to seemingly increase. And we actually saw this. We did a study where we looked at people texting and reading while they were driving, and you can see we did this just over 3 time periods. And over time, so we separated out these individuals based on the driver performance measures, based on risk and more conservative driving, based on how close they are, what's their propensity speed. And you'll see that over time, there are people that are risky actually were more willing to do more texting and spend more time looking at their devices compared to other things. So when we look at automation, it's really nice because it can extend the capabilities of the humans, but it can also make the humans more complacent during actually safety critical situations. So it's more vulnerable to system failures, to unexpected events, as well as cyber attacks. And there may not be as understanding of what's going on. So the operators in this case, based on all the previous talks, can actually experience degraded situation awareness of what's going on. They may actually have de-skilling as well as mode confusion as to what system is actually on or off. And then, of course, the over-reliance and the over-trust in the system. So, I've done this work where I've looked at, how it would actually, adaptation impact our ability to use things. So if we expect that, when we get a system, our goal is that that system should actually help increase or enhance our performance over time. And immediately when we get it, we use it in such a way that, yeah, this is really cool. But then over time, we kind of like plateau off. And then we can't actually operate at some optimum, so we just start to kind of like level off a little bit. And we're hoping that if we get from our car to, let's say, a rental car or another car that doesn't have that system, that we learn something from that system because we've been using it, we understand when something is going to occur. And so we have this positive transfer of behavior. But oftentimes what really happens is that we just go back to our normal driving mode, that what we had before. The worst case scenario is because we've had such high dependence on the system, we actually have a negative transfer of behavior. And then that's a situation where something actually bad can occur. We actually did a study to look at this. We've actually done several studies, so I'm just going to report on one, where we looked at drivers' behavior to lane keeping assist. So for those, I think all of you know what this is, but basically keeps the lanes. We actually wanted to see how people would adapt over time. We did use a driving simulator study, but we did this basically over 3 days for 8 different drives. So we had them do 3 different drives. We had 48 participants, a little bit over half use a lane keeping assist, and then we had another group that basically had no lane keeping assist so that we can just do a comparison. We had them basically have a baseline drive with no secondary tasks, no driver distractions, no anything. Then we had, for those that were in the automation group, we also had them just do the secondary task and then to try to compare. And we looked at basically the driving performance measures as well as their secondary task performance. And we also collected a measure called TDRT. And TDRT stands for the Tactile Detection and Response Task. This is actually based on an ISO standard that looks at assessing attentional workload for cognitive load. So it's as if you're driving and you're doing a distracting task, and how good are you able to detect pedestrians or other things on the road that might actually have an impact? So the way this system works is you basically you attach this vibrator to the person, oftentimes on their collarbone. There's a micro switch, so this thing buzzes, buzz, 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 and you're supposed to press whenever it buzzes. And so we actually measure cognitive workload based on the accuracy to perform this particular task, as well as how quickly they can respond to it. And then we also looked at their propensity to take risks. How often are they willing to engage in the secondary task while they're driving? And so what we see is that, so for the blue line here, this is the control group. These are for people who actually have no lane keeping assist. They just drive like what they normally will. And so you can see that over time, as you would expect, they become more and more used to the system, and they start missing less and less targets. And the treatment group, which is the lane keeping assist, we actually see that same thing. While over time, they would decrease. But what's very interesting is that once that system is taken away from them, and we tell them that the system is taken away, they actually miss more because they got used to basically the system operating for them. And so even though they went down, their number of misses actually goes up because now they have to actually take back control of the system. And we noticed this even for secondary task performance, where if you see the control group, both of them kind of increase in terms of doing these types of secondary tasks because they get engaged more. But the people that have the lane keeping assist, what happens is they actually engage more in more secondary tasks, and then when the system is taken away, they actually decrease because they're trying to still maintain control. So and we have also measures on driver performance, and if you look at the paper, we have some more information on that. But I guess just to sum up, so I kept it really short, is that what I want to do is just kind of get us to think about, when we model driver behavior, what are some of the things that we have to think about? And so for me, there's 5 things. Number 1, we have to understand what the system is, what the system limitations are, the user, and we talked a lot about that there's not just age and gender differences, but cultural differences as well as just geographical differences. Then the context that we're actually basically using the system, what tools that we are using to collect it, and we talked about driving simulation studies, but also on-road studies. But there's actually a whole space of different types of studies. Like we have colleagues that actually do things like ghost riders, where they actually hide somebody and pretend that they're actually driving an autonomous car. Or we have didactic interactions where somebody's in a simulator in one place and somebody's being a pedestrian simulator in another, and they're trying to interact with each other so that there's this vibrant needs to look at it. And then the types of data that we get from it is also incredibly important in how we actually bring all that together. And with that, I actually end the afternoon presentations, and I open up for questions. Good timing. Thank you. Thank you. Clapping for the timing or for the... Okay, so I do want to open up for questions. Yeah. Shamsi?
Okay, I will start. So you brought up de-skilling, which is super interesting because now we are in, let's assume, semi-autonomous vehicles where people are driving less. And then when it's a takeover or a handover, however you call it, you're requiring drivers to deal with situations that they're probably even less prepared for.
That is correct, yeah.
And so my question here is that can we design experiences or require people to still have to drive for X amount of time, or design tasks in a way maybe that causes them to drive and make sure that they're keeping their skills
That's
up to
a
date?
really excellent question. So earlier today, somebody talked about training, because training is going to become a really big issue in terms of like what are actually we training people, like even just at the younger level, and then how much regular training we have. You know, with pilots, they have, and commercial drivers, they have like a set number of hours that they have to actually be trained for. So those are things that people are looking at. Other things that people are looking at are, you know, given the fact that we're going to be using the cars differently, does that mean that, you know, every time something's not working the way that we expect, are we just going to go out and buy a new car? Which is, we're getting closer and closer to that. And I'll give you an example. Like right now, like we all use washing machines, right? But there was a time when people just washed clothes by hand. Now, if our washing machine is broken, do we go back and wash our clothes by hand, or do we go out and buy a new washing machine? Seriously. So we very rarely wash our clothes by hand anymore. So just something to kind of think about as we're moving forward. Yes.
I'm just wondering if you have also had a look at some of the naturalistic driving study data that have been collected by Virginia as well as in Australia. There are about 300 to 400 drivers across more than 4 months, and they actually had one where they installs a speed warning. So when before they have the speed warning device and after, and the treatment effect as well.
So I've actually looked at lots of naturalistic driving data. I didn't show it here just for time, but I've actually looked at the data from the SHARP 2, from the 100-car study, and also from the University of Michigan Transportation Research Institute, which actually collects a lot of field operational tests. Their field operational tests includes things like adaptive cruise control, lane departure warning, and it has before and after data. So actually, Eric mentioned earlier today that we met actually at a National Academies meeting, and at that National Academy meeting, I actually talked about the data from the naturalistic data looking at adaptive cruise control. And we actually see information about how people adapt to that system over time, and that we see differences in terms of people and what's their propensity to use things.
Just one thing to add as well. As in Australian context, we have the P-platers, for example, for the young drivers. And the impact on the different age groups are quite different.
Absolutely,
And because when they actually have the speed warning, they try to beat the system. So it's completely different.
I 100% agree. I'm just generalizing right now, but we've actually done, John Lee and I, we've actually done a lot of studies looking at teen drivers and young drivers. And oftentimes we will see differences in how feedback is actually, like he talked about coaching earlier. But we actually see that there are differences in how younger drivers actually retain feedback, and it varies based on the types of risks that they have and whether or not they're risk aware or risk seekers. So yes, I agree with you. Any other questions? Yeah, Albrecht? And by the way, just how they adapt to things over time too is very different.
I think the question of gamification, we see this in many other areas, and I think coming to the de-skilling, I think this is sort of one of those things, and we discussed if gamification is one issue that could go in there, and I think, but at the same time, whenever you sort of require people to do more, you lose time which you could drive automated, and so the other question that comes in, do we want to have the person in the car driving, taking over, or do you want to have a remote driver taking over? So I think that's something, again, in Europe at the moment with 5G coming and a high density of cities, we see the technical possibility that we can just basically, your car is coming into a difficult situation and you just hand it off, or it automatically is handed off to a professional driver who sits somewhere.
Yeah.
And I think my feeling is what I have seen so far, this is a much more realistic handoff than to the driver who has been sort of doing email and goes. Is there sort of something which goes in there?
Right now, the research that I've been doing is not really at that level of automation. I'm really focused more on the driver being within the car. But there is other people that are doing research. I don't know if anybody else can talk about that, where basically the car drops you off somewhere, and then actually goes back to your garage and waits for you until your work week is done. I don't know if somebody else has done some research on that. My research area has not focused on that. Yeah. Jesse, did you want to comment?
So we did something in teleoperation, not in the takeover scenario, but in that there's a remote driver driving a unmanned ground vehicle in a military kind of scenario. One of the biggest problem we have is delay. So because usually in some situations Wi-Fi is not good. There's huge delays between the signal you send the signal between from you sending the signal to the signal has reached the vehicle, and that delay makes the teleoperator their task very demanding. Yeah.
I think that's why at the moment the new standards for 5G there is some stuff which the new standards for 5G, which I think is now being rolled out over the next years, has this one operation mode where they think it's 50 milliseconds or less to get around that. But I think it's the question whether once we have coverage or if the car can drive automatically before that.
I think the goal for me was trying to understand, as we keep increasing in automation, how do people adapt to these systems? And what are the things that they would do differently that they would not do now? And how does that impact us, just overall in terms of use? And with that, I'm going to stop because I want to make sure that you guys have coffee. And I also want to make sure that we have time to kind of go through this stuff. So just like before you go for coffee, please write down one more thing, put it up on the whiteboard, and then we'll keep going.